Taylor Morris.
Oh, thank you so much. You're so kind. Thank you. Please, stop. Thank you. Oh, please, sit down. Thank you. All right, let's settle down. Today, on the Taylor Morris Show, we have our special annual physics episode. We have an exciting show for you today. We have Jessica, who plays Vanessa Vectors in the new movie Physics Fantasy, here to talk to you. We have the famous Sir Isaac Newton here to teach us about the laws of motion. Tessa is here to tell us of her new product, physics. We have our famous cooking episode and a special surprise for all you at the end of the show, so stay tuned after these messages.
Have you ever wanted to know why this ball will fall? Well, then you need physics. Physics will teach you about everything. Why you can hear me right now, or why you can see me right now. Let's take a look at what gravity is. The Earth is surrounded by a gravitational field. This is the Earth. Not really, let's just pretend. It is mapped using geographical field lines. The direction of the gravitational field is in the same direction as the object would accelerate if released in the field. So let's say we took this as the Earth, and my glasses were an object going near the field. It was in the field of the gravitational force, it would go and then that's how gravity works. You should get the new physics book. Thank you.
Welcome back to the Taylor Morris Show. Here on our special physics edition, here's Jessica here to talk to us about her movie Physics Fantasy. Oh, thank you for coming. Oh, please sit down. So, how are you?
I'm good, thanks.
Oh, that's awesome. Would you like some juice? Some Oasis?
I would love some.
Oh, that's awesome. All right. Great. So what's the movie about? How is it?
Well, I play Vanessa Vector, and she finds out that her hairdresser, who she becomes great friends with, is actually an undercover physics teacher. But she's been able to keep her identity a secret for so long because she works at a high school just in a town, and not very many people go there, but I don't want to spoil.
Oh, no. Thank you so much. That's awesome. How was it working with Mrs. Lostrocco?
Oh, she is fantastic. The red hair, love it. She's an actual physics teacher in real life, so she taught me so much. Like, she actually told me this great joke the other day. Would you like me to share it with you?
Yes, please.
Okay. A snail is driving an S car at 20 meters per second in 15 seconds. How far does the S car go? Get it?
Oh, I have a joke. Do you want to hear it?
Oh, okay.
Okay, ready? Knock.
Who's there?
Physics.
Physics who?
Physics you! Well, that's all the time we have. Thank you, Jessica. Alright, let's cut to commercial.
Have you ever wanted to know why you can hear me? Well, then you need physics. Physics will teach you about everything, like why you can get light from electricity and all about vectors. Let's see what sound is. If the ball is here, it can hear me pretty well. If the ball is over there, it can't hear me very well.
Welcome back to our physics special. Here's Sir Isaac Newton to teach us of his laws of motion.
Hello. Well, you see, I have 3 laws. The third one is the easiest. Come on, I'll show ya.
Are we going?
We just did it.
What?
You see, every action force has an equal but opposite reaction force. So the force applied on the ground applies the same force back on your foot, but an opposite. That's why we can walk.
Oh, cool.
Come on, let's learn about the second law. Law 2. I have a bucket full of water and a bucket full of nothing. If an externally unbalanced force acts upon an object, the object will accelerate in the direction of the force. The object will be directly proportional to its force, and the acceleration of the object is inversely proportional to its mass. That is why it is easier to push the lighter bucket rather than the bucket full of water, because the bucket full of water is heavier. Law 3, come on! Golly gee, I meant Law 1! Moving at a constant velocity will maintain that constant velocity until acted upon by an externally unbalanced force. While we were driving, our bodies were maintaining a constant velocity with the vehicle until I stepped on the brakes and we moved forward because our bodies wanted to keep maintaining that constant velocity that was being produced by the car.
Ever wanted to know why I can move this ball? Well, then you need physics. Physics will teach you about everything. So let's try an experiment with this ball. I'm going to put force on this ball.
Not again!
This is Cooking with Taylor.
Hi, we're gonna make some eggs today. The first thing you do is wash your hands, which I already did. So the next thing we need to do is turn on the stove. See, it's on. The electrical energy through the stove is transformed into heat and radiant energy on the stove top. Then we put our pan on, and since it's a metal, the heat is conducted through the frying pan, heating the egg, and the egg will produce waste energy of sound. So we place our frying pan on here, and let it heat. This is our egg. We have a lot of eggs. Just waiting for this to heat up. Okay. Heat's been transferred through the pan. We can cook an egg. So we crack it. Make sure you don't get any eggshells in there.
That looks good.
I guess it does, Mystery.
Oh, physics.
Let's add some salt and pepper for flavor.
It's not coming up. That's good.
We are experiencing technical difficulties. Please stand by.
Do you want to flip the egg? Because I can't.
Oh, I can flip an egg.
Okay. It's not even cooking. Okay. Well, it is.
We're gonna flip the egg now. Isn't cooked enough to flip it. Should have buttered the pan.
Good.
Why did you butter the pan?
Keep going.
I can't put it. You didn't butter the pan.
It doesn't matter if it breaks.
It's not going to be an egg anymore.
This is how you break an egg.
Oh, it's broken.
Yay!
This is how you don't cook eggs properly.
Don't forget to garnish your food before feeding it to your clients. Here you go. Wasn't that food delicious? We're here with Tessa, the author of her new book, Physics, the 11th out of her series of the Science Saga. Tessa, would you like to tell us about your book, please?
I would love to tell you about my book. Really? I'd love to tell everyone about my book and about physics. Did you know you use physics every day?
No, I didn't.
Wow, where has she been? Well, can I read you a passage out of my
Oh,
book?
please do, please.
Okay, well this passage I have selected is about friction.
Oh, friction.
Eyes are getting a little bad nowadays.
Yeah.
Friction is necessary.
Is it?
When a car is starting to move or a person is walking or running, friction is needed.
Oh.
Without friction, cars cannot slow down or turn corners.
That would be awful.
It would be awful. Now that's just chapter 3. Now let's read the next 50 chapters.
Oh,
okay?
no, it's okay. That's all the time we have
Well,
on our show
I
today. Here is our special surprise that you've been that you've been waiting for this whole show. Have a good night.
Today I don't feel like doing anything. I just wanna do my physics. Don't feel like doing chemistry, so shut the door and let me be. 'Cause today I swear I'm not doing bio. I wanna calculate the speed of my car while I'm driving, divide distance by time, and now we're flying. No one